Welcome to September 10th LeetCode Challenge, Arithmetic Slice 2 Subsequence. Given an integer array nums, return the num of all the arithmetic subsequences of nums. A sequence of numbers is called arithmetic if it consists of at least 3 elements, and if the differences between any two consecutive elements is the same. For example, these 3 are the arithmetic sequences, and this one is not. It doesn't really do much explanation, but I'll describe it down there below in a bit. Subsequence of an array is a sequence that can be formed by removing some elements, possibly none, from the array. For example, 2, 5, 10 is a subsequence of this larger array right here. Test case is generated so that fits a 32-bit integer. So we see that we have an array nums here, and we have a bunch of is counting how the number of arithmetic subsequences from nums. So we're given this subsequence, the sequence here, and the subsequence of at least 3 elements is all these at least contain at least 3, and we want to find the difference between the arithmetic sum between any 2 consecutive elements is the same. So the difference between 2 to 4 to 6, the difference is 2. The difference between 4, 6, and 8, that's also 2. The difference between 6, 8 is 2. The difference between 8 and 10 is 2. The difference between 2, 4, 6, and 8 is also 2 in between. 4, 6, 8, and 10, the difference between any 2 consecutive element is 2. The difference between 2, 4, 6, 8, and 10, that's also a 2 in between. The difference between 2 and 6 and 10, the difference of that is 4. Right, and that's kind of the gist behind the explanation of the question. For this one, we have all 5 elements being 7, so the difference between any of them is 0, and therefore any subsequence from this array you can make 16 subsequences from an array of 5, and they'll be arithmetically different subsequence of each other. So let's see, the nums is between there and nums at I. So the approach to this is, as I was going through this, I was thinking dynamic programming is the approach we're going to do, and it's going to be basically creating a dynamic programming array of a 2-dimensional array where we're going to keep track of at least store the numbers in the sequence with each possible interval before moving to nums I. So it's going to be that basically a nested for loop type of approach. So for example, if you have, I'll copy this example here. You have nums at there. If you create dynamic programming, let's say in x3, you will have the subset. Let's say you can make 6. The difference between 6, the difference between 1, I should say, is 6 times. The difference between 4, you can make that once. And the difference between 2, you can make 3 times. 2, 3 times. Alright, so that means that that essentially means that for 6, the difference of 6, you can make an array that's basically 2, and this is of length 2, by the way. So you can make one of those. If you have a sequence of 4, difference of 4, I should say, then you can make the array, for instance, 4, 8, and that's of length 4. Or you can make it how many times is 1? And then you have a difference of 2, which you can make, for instance, 2, 4, 6, 8 as an example, and that's of length. Oh, I should include that into there. Length of 2, 4, 6, and you can make 3 of this. Alright, so for each sequence of nums at position I, we're just going to add the length minus 1 to get the final answer. Alright, let's go about doing this. So the first thing I want to develop is a dynamic programming array. So the DP. So I'm going to use a collections default counter here. Default dict. This can be of int, type int, for each space or element inside the range of length of nums. Actually, I'm just gonna do n here equals the length of nums. Just make it look a little bit nicer. And then I'm gonna have the output be 0, and that's gonna store our counter. So next thing I'm going to do is do a for loop for I in range of n, for j in range of I. We are going to do a couple things. We're going to first find the difference between the nums at element I and the difference between I'll just type it down. Difference in nums at element I minus nums at element j, or index j. So that's going to be our difference. And this is basically the difference between any two consecutive elements. And then what we're going to do is that we are going to redefine our dynamic programming array at index I and the difference, and that's going to be incremented once. Right? We have that. If the difference is in our dynamic programming array index j, we are going to also update our difference by 1. No, not by 1, by the dynamic programming array index j and difference. And then we're going to increment our output by dynamic programming index j and difference. And we want to return our answer, return our output. Let's see, run code. Alright, looks like it's good. Alright, accepted. So this is a ranked hard one. It is hard in terms of this component right here, the meat of it, and understanding how the question is solved. It takes this is like dynamic programming, like straight up to this core. So if you really understand how to do that, then it should be, even though I don't understand completely in terms of how to describe this a little bit better, but time complexity is big O of n squared because we have a nested loop here. So basically we go through nums n squared times, so big O of n squared. Space complexity is we store everything in a dynamic programming array, but it's also a double array, so it'd be big O of n squared as well. Let me see. So using dynamic programming is our approach, and yeah, space complexity is also big O of n squared, because for each ith position, we need to store our most n distinct common differences, so the total space complexity is big O of n. Alright, that is it. Have yourself a great day, guys.